So, welcome everyone to our session. My name is Maria Pergi, and I work for the Institute for Advanced Sustainability Studies in Potsdam. I am one of the session organizers. Unfortunately, the other two session organizers could not make it today, so I will be chairing the session on my own. Before I give the floor to the presenters today, I'll just give a brief motivation of the purpose of the session. So we know that in order to achieve the Paris climate targets, we need an energy transition, and in order to do that, we often focus on the benefits that this includes, but there's also going to be some risks and some inequalities involved that are linked to unequal access to capital and finance. And therefore, we think it's important, since this happens a lot with Global South countries, to focus on countries of the Global South and assess these potential unequal impacts and potential increased difficulties to achieve this transition in this region. And we think energy transition scenario studies can help answer these questions by identifying pathways to different energy futures and by showing under which conditions these futures can be achieved. Okay, so for each presentation, we will have a 10 minutes presentation and then 10 minutes Q&A. And yes, so I give the floor to the first presenter, which is Xing-Xuan Chen from the Copernicus Institute of Sustainable Development, Faculty of Geoscience, Utrecht University, who will be presenting on using decomposition analysis to identify major contributors to carbon neutrality across sectors in OECD and non-OECD regions.
Thank you, Maria, for the introduction. Yeah, so my name is Xing-Xuan, and today I want to present my work with the image team to identify the major contributors to carbon neutrality across two regions, OECD and non-OECD regions. Okay, go. Yeah. So the goal of this study is to, so with the let me start from the image model. So with the with the IAM model, we can project or we can model different emission from different sources, like the figures showed here from industry, transport, residential. There are different emission contributors, but we don't know we are not sure about the key drivers, like under these sectors. So in this research, we want to identify the key drivers of across these sectors, but also we want to compare different regions, like to see if there are differences between the key contributors across different regions. So by doing that, we used 3 scenarios here, because we want to investigate how the carbon neutrality. So we have the one scenario is baseline scenario, which is SSP2 baseline, like business as usual scenario, and the other 2 scenarios are 1.5 degree scenario, which means you reach the greenhouse gas emission caused temperature increase within 1.5 degrees by the end of century. And these 2 scenarios are renewable scenario and lifestyle scenario. With renewable scenario means we have higher electrification rate and more transition to renewable energies. With lifestyle scenario, it is designed as like consumers change their behavior towards more like lower greenhouse gas emission lifestyles. For example, consume less meat or change to less carbon intensity transportation and so on. And then this is to show the picture of these 3 scenarios. So in the left, you see the 2030, the year of 2030, and the first column is the baseline scenario, and then second and third is the renewable and lifestyle. And you see from power sector, industry sector, and the transport sector, the CO2 emissions still quite high. And we chose these three sectors because they are the main emission contributors across all the sectors. And on the right-hand side is 2050, and you can see in the mitigation scenarios, actually, some sectors can reach net zero, even negative emissions, because in power sector is with CCS, and in industry sector is also with CCS in industrial process. And transport is 1 or 1.7 gigaton CO2 emission, but then still close to net zero. But we want to know, like how can we get there? Like, and also across the regions, are there differences? So next, we show the OECD and non-OECD regions. The upper one is OECD region, which you can see is blue. Blue means 0 to negative, and mainly across these three different sectors, the emission is actually reaching net zero. And the total emission, is not only these three sectors, the total emission from all the sectors actually is also close to zero in the mitigation scenarios. And in the, I can actually move, right? So in the in the non-OECD regions, you can see the residual emissions are here actually. And while from the main emission contributors in 2015, well, they're actually doing better in 2050, but then we want to know, like, okay, then why or how are you going to reach this almost net zero, and what are the main contributors in power sector, in industry sector, in transport sector? So that's why next we use this methodology, which called decomposition analysis. I'm not going into these mathematical details, but the main, the key message or the key element of this methodology is by defining the Kaya equation, then we can calculate the contribution of different factors. So I hope it's easy to read. So on the first one, the Kaya equation, I don't know if you are familiar with that, but it's CO2 or the greenhouse gas emission equals to the different terms times to each other, and then in the end we minus CCS, but it's an extra term. So the first one is population times activity level and times the structural change, which differs from different mode or different sectors, times efficiency and times carbon intensity. In the end, minus CCS, in the end, equals to the total CO2 emission in each sector. So this is actually the equation we developed from in this research, because it can be it's a general equation, but it can be used in different sectors. So, for example, in power sector, you can see the population, activity, fuel switch, like the electrification, the renewable share, and then also energy efficiency and CO2 intensity. So by defining these factors, we can calculate what are the contributions to CO2 mitigation or greenhouse gas mitigation. And then, and this is the industry sector, so it's a bit different from the power sector, because here is the electrification rate instead of a renewable share. But then, the other terms are similar here. And then this is the transport sector, and here you can see the activity is by the travel distance divided by population. So it can change across different sectors with different activities. And then here we also include different travel mode. So walk, cycle, bus, car, train, and high-speed train, and airplane. And here we have the mode switch between these different travel mode. And we don't have CCS here because in transport we don't have CCS. Okay, and also residential But I'm not going to show the residential result here, but if you are interested, you can approach me after this session. Okay, here comes the result. So in power sector, so the waterfall plot is usually how we display the decomposition analysis result. So as I introduced before, we have different terms identified here. So population is the first one, and activity is the second one, and renewable share, and efficiency, and in the intensity of CO2 intensity, and CCS. So in the first, the left column, it shows baseline and between 2015 and 2050. So the emission changes between 2015 and 2050. And the contribution from population actually, I will do this, actually increased. So the population increased between 2015 and 2050, both in OECD and non-OECD region, but the increase is actually more in non-OECD region, so it contributes to more CO2 emission, and also the activity of like power generation also increase in non-OECD region, which is the bottom panel, and that's comparing to OECD, you see a big differences. And then this is the first column is the baseline scenario, and the second and third column, I apologize, this figure really needs more time to understand, but I will try my best to explain it. So the second and third columns means from baseline, compare the 2050 level, 2050 emission between the baseline and the mitigation scenario. So that, for example, here means in the renewable scenario, the 2050 level mitigation, 2050 level CO2 emission is lower than the baseline scenario. So the baseline scenario is here, like 2050, and here is actually negative, like -2 gigaton CO2 emission, and that's because of here CCS is the main contributor. And the same case, actually, in non-OECD region, the main contributor is switching to renewable R here instead of CCS. And then, so you do see differences between different regions. And in lifestyle, again, the changing to more renewable share is more important in in increasing CCS technology, and that's actually because in the OECD region, in the baseline, it's already with higher renewable share. Yeah, so it's already with higher renewable share, and then so of course compared to 1.5 degree scenarios, CCS is more important. But in non-OECD regions, you have more chance to increase the renewable share. Okay, so I just know I have 1 minute left, so I will just skip to the conclusion. So this is the conclusion figure. You can see by the decomposition analysis, and the OECD, the non-OECD region have more opportunity or capacity to do the mitigation. Like here is almost to -20 in mitigation in power sector, but then in OECD region is less. So that's also there are differences across sectors. In the transport sector, in OECD region, electrification is more important, and in the power sector, CCS is more important in OECD region. And in non-OECD region, the efficiency improvement is more important in industry and transport, and in the power generation, activity change and renewable, changing to renewable energy is more important. So yeah, just to be short, this is a useful tool to investigate what are the opportunities of decarbonization across different regions, and also to show the different trait or characteristics of different sectors. And it's useful for energy policy making. And yeah, that's all. But sorry for speed up in the end. But thanks for listening, and we can discuss more in the discussion session. Yeah, thanks.
Thank you very much. Any questions?
So I was trying to follow the waterfalls, but now I'm going to just go to your summary at the very last slide, where you said that you omitted changes in activity as significant in the OECD regions, but they were significant in the non-OECD regions. Is there an equity issue there, that the OECD regions, the modelers did not put in changes in activity level, although there's quite a lot that we could do with our lifestyles. And I'm kind of curious about the 1.5 degree C lifestyle, because it ought to have activity.
Yeah, can I show the slide? Yeah, so you mean the lifestyle, but then the differences between OECD and non-OECD, right? Yeah, so because in our scenario or in our model, the transition or the lifestyle transition already happened. Well, gradually happened in OECD region already. So that's why, because it happened earlier, so it has less opportunity or contribution in the future. Yeah, so that's because the assumption in our model, in the future, because the most of non-OECD regions are still developing. I don't want to use that term, but and so there are more opportunities to contribute to carbon mitigation by reducing their activities. Yeah, thanks.
One more question.
Hi, I was simply wondering if the tool will be made available also to other teams. That could be useful, maybe.
Yes, thanks for this question. So the tool is now developed, and the code are in Python. So and they're online, and so if you can I show the slide again? So if you follow this, well, just try to go to this paper, then you can find it with the link to the data or the data source, and also the code I use. So it's online. So yeah, I think it's useful. Also maybe compare different modeling result with different models. So yeah, I encourage you to use that. Thanks.
Thank you. I was wondering, I saw your waterfall chart on the power sector, and I saw that for the OECD countries, the activity level was actually not very strongly increasing, but shouldn't it increase with the electrification of other sectors, so electrification of transport, of heating, of industry, then the activity would actually quite significantly increase, I guess, right?
Yes. So indeed, I think there's two scenarios. So in the renewable scenario, the activity, because it's changing to more renewable, so you can see the activity level is actually increasing. Also non-OECD region increase more than the lifestyle scenario, and also a bit more than the baseline scenario. So it does show the more increase in OECD region, but Yeah, yes. I think it's depends on in which sector the electrification happened. I think, and for the scenario we use here is mainly in the transport sector, and in industry sector a bit, but more electrification. But yeah, with more electrification, but more like switching to renewable source resources. So the electrification here doesn't really pick up that much, but it does show the increase there. Yeah. Thanks.
Okay, then. Thank you very much. So we will move. We will move now to the next presenter, Esther Schuch from Institute for Advanced Sustainability Studies, who will be presenting a study on breaking the carbon locking, a scenario analysis of the Malaysian energy transition. And now I will be using the cards.
Because you don't trust me, okay. Okay. There's me never using PowerPoint. It's just down there. Thanks. Okay, yeah, so as you see, the title is kind of long, so I will not repeat it. It's joint work with the partners from Malaysia and the Institute for the Advanced Sustainability Studies. And in contrast to all the modeling exercises we have seen today, we are trying to model something that is qualitative. So it's going to be a bit of a different kind of exercise, and I hope I can answer all the questions afterwards. And why are we looking at on Malaysia in general? Malaysia is a specific kind of emerging economy in Southeast Asia because it actually has a high carbon industry traditionally, and it also has a strong renewable energy sector. So there is a bit of a trade-off to be had here. And what does it mean? It's the second biggest producer of oil and LNG in Southeast Asia, actually. But it's also the biggest palm oil and third largest solar photovoltaic cell producer worldwide. And so there are a bit of, also in terms of like where does the industry policy go, there are a bit of trade-offs to be had in here. And we also see a bit of institutional inertia, I might say, in some parts. So we thought it would be interesting to actually look at these kind of institutional designs, if we can model them and how they shape our, how they shape basically the energy transition. And just to give you a brief overview on Malaysia, I'm not going to go into detail of the whole energy sector, but so far we are mainly having petroleum, then we have natural gas, then we have coal, and only 6% in 2019 were renewable. That is particularly exciting if you think about that they want to be carbon neutral by 2050. So there is a bit of a challenge to be had, and we were exploring with the local partners how we can make this happen in terms of like where do we need the policy to go. And there's a lot of potential in Malaysia. We have, depending on the region, we have mainly solar, but also wind, hydro, and so it's not a matter of we can't do it, it's more like how can we actually unlock the system to make the shift from carbon to renewable. And yeah, as I said before, we try to model the qualitative factors, and what do I mean with this? It's mainly institutional things, and we use cross-impact balances for it. And the software is called Scenario Wizard. It's open source. If you're interested, it's easy to look. And there's also a good manual, actually, how to use it. So, and it does enable us to quantify measures that are usually hard to quantify, like political stability or the political economy structure. And then we are also able how these different factors actually interact with each other, like what kind of system dynamics are happening if there was a change in political economy structure. What would that mean for the energy transition in Malaysia? So to do this, it was a very extensive process, I have to say. We started with a global regional workshop in 2020. 20 already, 21. We started in 2021, and due to COVID, of course, all online. And what we did, we invited really from every region of the world. We had like energy experts, depending, and that was like academics, but also industry people taking part in this workshop. And we just discussed which factors are important in a global south context of the energy transition. But of course, that comes out with a broad band of scenarios, of variables. Then we went in a smaller workshop where we had just experts for Southeast Asia and narrowed the previously defined variables down, which ones are important for Southeast Asia, and might we have missed some that are not so important for the overall global south, but more specific to Southeast Asia. And then we had like expert interviews in which we defined Malaysian expert interviews, in which we narrowed down all these big variable ranges to 9 variables that we can actually model in our model. So of course, it's not complete, it's not every variable that there is, but it's what the local experts think is the most important. So there's a nice kind of shape. And here, so it's really like right now we are only here, right? This is our process. So there's a lot more to come in how we model this. And once we had these 9 variables, of course, we need to know how they interact with each other. And that was done in a... first, I should show you which variables we actually have, I guess. So that's how it looks. So I will take a more intuitive one in this context, maybe. So let's say we had electricity market structure. And of course, there are a lot of details how the electricity market is structured. But in our case, we had to break it down in very basic kind of end states. And here we say it's either a monopoly, an oligopoly, or perfect competition. And of course, there are like nuances in between, but the local experts were asked to identify which they find is most likely to happen, for example. And yeah, there were also debates to be had. What does it actually mean, perfect competition? But I spare you this debate we had. And so we had these 9 variables with the end states. And then we had another workshop for 2 days in Malaysia. And I joined online due to COVID. So we asked the experts to actually discuss which end states interact with which ones. So maybe I should quickly go back. One example would be we have high investments in renewables, and people often said, oh, this will probably lead to fast green growth, right? I mean, post-COVID. So this was one of the most often places, or that will lead to a sustainable expansion in infrastructure development. These kind of connections we were looking for. And people were debating a lot, as you can imagine, 22 experts from different sectors, not only like academia, but industry, NGOs, all sorts of different patterns we had. But we only modeled the ones that the people agreed on. So it's not that we have, if one person said that should be a connection and other people disputed, we said, okay, this we won't model. We have different versions afterwards, but what I will present is what the experts agreed on. And then we ran the modeling. Then we had another workshop with the same people to discuss whether these results actually make sense and whether they think that we captured adequately what's happening. And this is how these influence diagrams looked like. And this is one group on the first day. So it was a cool exercise, I have to say. But of course, this is hard to understand here, right? So we did the modeling part. And I will present now the first output we found. So on the upper quadrant, it's what we call active factors. So these factors are really shaping the system. They are having an impact on all the different factors that we also have. And we can see already the political economy structure and the political stability are there. That is not so surprising, I think. COVID recovery surprised the participant and surprised us. But yeah, in the end, it also did make sense, we figured, but in the first intuitive part, because people were debating whether it should be included in the first place in the modeling part. And yeah, so these are our active ones. And then we also have the passive ones, which is down here, which means they really don't they don't shape the system at all, because on these variables that we identify, that don't have a pushing effect, basically. And I find this particularly interesting because we have investments in renewable, which I would have thought intuitively is a thing that if you want to focus on an energy transition, you have to ramp up investment. But apparently here, just ramping up investment will not give us towards an energy transition. There are like constraining factors like political economy structure that is more likely to hamper. So already that was a big surprise, and we had also policymakers in the room who were like, I was right not to support this financing, right? So we also had in total 26 scenarios, and I will not present them all. But to summarize, we found that all of them, and we modeled till 2050, were either run by centralized or decentralized renewable energy mainly. And we didn't have a single scenario where the monopoly in the electricity market prevailed, which is also partly because there was a debate whether it's right now more already an oligopoly than a monopoly. So it's and the scenarios I want to talk a bit about these ones. So we also asked them, what is the current system looking like, right? So because we don't have a baseline as per se as when you use the nicely formatted SSPS. So we have here, this is what they defined as a current system. Then we also asked them, where do we want to be by 2050, so we can actually measure where we want to go. This is the desirable energy system. And then we try to see if we actually reach this scenario, and we don't in our modeling exercise. The kind of combinations we have will not lead us to this monopoly, this scenario, but I depicted the ones that are closest to the ones that where we want to go. So, and then we have here, they are closest to the one that was identified, but starting from this baseline, we cannot identify a pathway how we can reach this scenario. So the one we actually reach that is kind of close to where we want to go is this one. So from now on, we will talk about how we get from here to here. And to identify these pathways, we use succession analysis, which basically means it looks for stable scenarios if you change one variable in the system, and it will like identify which variables have to change in order to reach and arrive at a new stable scenario. And that looks like this. So we changed actually state-centered to liberal market. And we also changed post-COVID to fast green growth because we didn't actually find a pathway if you only work on one factor in the system. So you always have to have a combination of factors to unlock the system. And here we see the next one is, so once you actually are more in a liberal market, then high investments actually make sense to do because they're actually changing stuff. Then we ramp up investments. And then, interestingly, we don't stay in this liberal market. We go back towards a global, towards a coordinated market. We also move to the oligopoly, but as we said before, we are on the verge to being in an oligopoly anyway. Then we finally make the shift from centralized fossil fuels to centralized renewables. We also have political stability going up to high, and then we have sustainable expansion in the infrastructure development. And in the end, we move back to a state-centered system. So it's not to say that we really have to revamp the Malaysian system completely. It's more that we need to loosen up a bit, like with the political structure that we have, and give some leeway to actually make these changes happen. And that was basically how we went through a lot of these pathways, and discussed them with the policymaker, the participants of the workshop, and they confirmed it does make sense. So I'm kind of confident presenting you these results. And we started discussing what this means for policy implications with them, because of course that is the whole point of the exercise for us. And first of all, we found it really useful to know just using investments is not the way to go. And that since we had these 9 factors identified, we also saw it's a very rigid system that needs specific loosening up. And of course, it's a bit difficult to tell these policymakers, you know, you need to move away from power. you need to give it up to more stakeholders and stuff. So there were also discussions whether how the curriculum in school could be changed to be a more democratically aware kind of citizen. So there were really broad-reaching like policies in place. Were policies in place? No, it was like a very open-minded workshop. Basically, it's like the hindsight. So it's and it's not my phone. Just acknowledgement so that the donors are happy, and looking forward to discussions.
Great, thank you, Esther. Any questions?
Thank you very much. No, it was very interesting to see this different approach from what we might see usually like purely model-driven pathways of decarbonization. Here instead you're more going bottom-up from the stakeholders to the potential, what will happen potentially. My question is a bit if you and your team had thought how these two approaches, so the approach you had and the more classical like integrated assessment modeling or energy modeling perspective, which is driven purely by numbers, can go together, because in my view they really complement each other in a way. So yeah.
And it's really cool that you asked, because the colleague who couldn't be here was supposed to run the session with us. He's actually currently working on combining SSPS data with the outputs we have, because we did this also for Jordan and Chile and Kenya. So and now and there's also a global set. So we hope to have some of these combined papers out.
Maybe we can take a few questions.
You mentioned in the beginning that you did this meeting and discussion with the stakeholders and the energy experts first globally, and then you kind of scaled down to the regional or country scope. And I was wondering, what were the differences that the experts and the stakeholders were outlining as a priorities when it was on the global level or when it was on the local Malaysian or South Asia level?
Thank you. My name is Laurens Spilman from Rocky Mountain Institute, working on transitions and the modeling of them. And actually, in a previous life, worked in agriculture in palm oil, cocoa, and coffee. So this is like two worlds of mine being combined. And first of all, congratulations, I think, on the study. I appreciate the order of going from, okay, what will the future system look like? Not thinking about the modeling or all kinds of other different pieces. What does it look like? It reminded me a bit of the presentation this morning of what the future states of an energy system can look like. What will the political economy look like, etc. So I think that's really well done. And I was wondering, you mentioned a couple of next steps in terms of further quantifying it and modeling it in your first slides. And I was wondering, what are the next steps for this study? What are you planning on doing beyond this piece?
So that was a cool application of CIB. I have a technical question. So when you were saying about reaching the ideal scenario from the current one using succession analysis, so one thing that you can do with that is, since each scenario has a basin of attraction under succession analysis, if you start with the ideal and looked at its basin of attraction and asked, is there some tweak you could do to the current to move it into the basin of attraction of your ideal so it starts to, just wondered if that was something you considered.
I actually will start with the technical one first, because I think that's I think I can answer this kind of quick, because I had a short look at the basin of attraction so far, but since neither the desired nor the other one is a stable scenario, then it's already a problem. So that's why I think it's a quick answer. On the differences on regional, global, I think when we discussed global ones, it was very broad. We mainly discussed like, access to finance was mentioned a lot, like also, and then like trade barriers. Knowledge exchange was a lot, and also, but it was very like more the technical stuff and very like broad. And on regional, for Southeast Asia, a lot the role of China was discussed a lot, right? Because that's an obvious point in Southeast Asia, and like the dominance of, and it really all depended on like how is China going to do this and that and ABC and the Green Road Belt and all these kind of debates to be had. But then in terms of when we go to Malaysia, because Malaysia is kind of actually, since I'm not saying which expert said it, I can say it. He was like, it's good for us that China doesn't like follow like all the most democratic approaches and things, because that means trade partners come to us. They come to Malaysia to buy our PV, and we buy ours from China because we don't have this kind of match. But so it was more like really what drives Malaysia, and on also Southeast Asia was the only region, if I remember correct, that really focused on like behavioral patterns of like what does a consumer do, because the AC is a huge problem because it's so hot all the time, and people just ramp it up and cool down to 15 degrees to be able to put on a jacket, right? I mean, this is happens a lot, and it's a bit of this awareness problem that people were really, in South Asia, people were really saying we need to focus on the behavioral part. But then in Malaysia, it didn't make it to the last final ones. And then it was where we are going with this one. I mean, this study so far, we probably will more or less keep it like there's a bit more tweaks, but there is plans for the other case studies, of course, to be published, and then there's a comparative one, and we have a methodological paper that is hopefully coming out kind of soon on like how to do these workshops and get the expert interviews and all these combined to like actually make it to a modeling stage like this. Yeah, actually, we do a lot, sounds like it.
I think we have time for one more question, if there is any.
Yes. I was really wondering about that. Stakeholders actually indicated that it's good to move from monopoly to oligopoly. Can you expand a little bit on that? Because usually you would see, that especially when you mentioned that it's already in the verge of being an oligopoly, then one of the priorities usually seen in other case studies is to move towards more competitive market that will also drive the decarbonization, right?
I can speculate by reading between the lines of the discussions, but I mean, what people basically said is an oligopoly is already better than what the monopoly would do, especially because it's so state-driven in Malaysia. Everything is super top-down, so already an oligopoly would be a big advancement in terms of like giving people a bit more of a say. And I think it's also a bit of a reality check. I mean, we asked them to go all out and go like crazy with ideas. If they can have one way of imagining it, they should. But they were really like, yeah, a liberal market is just, there were few connections in any direction. But I think it's driven by the top-down structure in total. So, and I mean, since we also had government officials in this workshop, there's also this risk that they might not be happy to like say like, like the role of the state, especially in the electricity market, should be cut down, and there's always this kind of risk.
Thank you. And now we will hear from Giacomo Falzetta, who will present a study using scenarios for solar irrigation uptake in Africa and their development potential.
Thank you. Should I open the full screen? Okay. Okay, so we change geography, we change topic, we change approach. So here we're talking about a technological assessment, that is to say solar irrigation in the agricultural sector, in Africa, in particular in sub-Saharan Africa. And this is a study seeking to quantify the economic feasibility and the potential benefits in terms of development from different perspectives of technology. I am Giacomo Falchetta, and this work is part of the LIPRI project, which is a project on cooperation on renewable energy between the European Union and the African Union. So just to provide some background, these are some trends, recent trends in sub-Saharan Africa in terms of demographics and in terms of some, let's say, sustainability indicators, some dimensions which are also captured by the SDGs. And somehow the main bottom line is that the rural population in the continent is rising steeply, irrespective of urbanization. So the projections bring this to about 900 million rural dwellers in 2050 in a, let's say, medium scenario. And looking at the trends of different development indicators, it's clear that we are not in line to meet many of the Sustainable Development Goals by 2030. Some of the most crucial are, for instance, access to energy or food security, etc. So also in this map, it's interesting, it's a bivariate map where you can see some spatially overlapping gaps in terms of energy and water. So this map gives you an idea of where the deeper concentrations of energy access and irrigation water gap is presented. So you can see that these two important dimensions are overlapping in several highly populated areas of the continent. So the big question that we are trying to assess a bit is whether there is potential also from a techno-economic point of view to leverage these synergies to have infrastructure that can supply synergetically these gaps, basically. But to do that, given the complexity of the dynamics, we need an integrated framework that captures multiple dimensions. So this study aims to generate some spatially explicit scenarios consistent with the SSPs, RCPs, in terms of future water and energy demand from the agricultural sector, in particular for purposes of irrigation, and the related technological needs and investment requirements, focusing on solar pumps, with the idea of comparing costs with potential benefits and some non-monetary co-benefits, such as food production or access to energy. Okay. So how do we go doing this? We have an integrated framework that you can see with 4 main modules, let's say. One module which is seeking to estimate the irrigation requirements to close what we call the irrigation gap. That is the basically lack of irrigation supply, so the use of irrigation, of deficit irrigation practices, for instance, by using solely rain-fed irrigation. And this is a quantification of how much water, given current cropping and climate, is required to close this gap. And then, of course, this water needs to be sourced, so it can be sourced from underground aquifers or from surface water bodies. So this second module seeks to estimate how much energy would be required to pump this type of energy to supply it. And then also we exploit this crop evapotranspiration and growth model, which can give an idea of the response, yield response, due to the closing the irrigation gap, basically, so how much the yield could benefit from this. So we can have some increase in production estimates. And this ultimately can be used to calculate and compare some potential costs and benefits of installing the technology, and in turn of revenue streams that could accrue from these improvements in productivity and in stability of the yields. And the last module somehow tries to derive some results which are from the local to the national and regional level. I will be quick just to present some input data. We use spatially explicit data sets on agricultural land, on climate, historical climate, to estimate with this water evapotranspiration model what are these irrigation water needs, like a water gap. And then we source water sources, the location and characteristic of potential water sources to withdraw this water that could be used for irrigation. And then since we're talking about solar irrigation, so standalone modules, we have some solar potential and cost data sets that give an idea of the size of the system and the cost of the system in different settings. We do this for a baseline, and then we seek to do this in terms of some scenarios to see what could be the relevance of climate change in terms of basically impacts on the water demand, so the needs of crops for water for irrigation, but also in terms of availability of groundwater, for instance, so in terms of possibility to supply the required amount of water. Okay, maybe I will go quick because the time is passing fast, but so the idea is also to have an idea of where it's possible, it's economically and technically feasible to close this irrigation gap, but also we want to see where this can be done sustainably. So we have both an unbounded pumping scenario and an environmental flows preservation scenario where we seek to ensure that we don't overexploit the reservoir recharge, okay? So to show some baseline results, these are, for instance, monthly profiles of water and energy demand for closing this irrigation gap in different sub-regions of sub-Saharan Africa and related energy needs. And these are indeed, as you can see, spatially explicit, so we can have an idea of where are the hotspots of this demand for irrigation and irrigation infrastructure. We are talking about small-scale pumps. So, as you might know, in sub-Saharan Africa, most farming is smallholder farming. So we size the infrastructure accordingly to small-size agriculture. And then here are some maps which show basically an idea of the economic outputs of the analysis. So in terms of revenues, profits, which locally depend on a lot of things, on the local cropping, on the local potential for production of solar energy, on the availability of water sources, etc., etc., etc. So our result, interesting, this is of course preliminary, is that we see a lot of potential for groundwater withdrawal, because in large parts of Africa, groundwater is quite accessible, it's not really deep. So this is interesting, but also somehow a warning that must be factored in terms of consideration on overexploitation of the aquifers, etc. And then doing a bit this comparison of cost and benefits. Sorry if I don't have time to go into all the details. We can have also some idea of what could be the payback time of the technology in different locations. There are a number of underlying parameters upon which costs were set, for instance, and these were discussed within our project. We did focus groups with local stakeholders, local farming associations, developers, to get a sense of really what are the local costs, etc., to tailor a bit our assumptions. Then, you can see for different regions what are the discounted costs and revenues in the future in sites where we find this technology to be economically feasible. I will be very quickly to show as well these estimations, which are some potential co-benefits in terms of food security. So where, thanks to this growth in production, there could be increased generation of food and therefore calories and proteins, etc. And also, these are all baseline results. And as I was saying, then we seek to see what happens with climate change, for instance. So here you have the red bar, which is a baseline scenario of historical climate. And then you have the other two bars, which are SSP 245 and 585, which show growing requirements for water, for irrigation, to meet the demand of the current crops. And interestingly, also looking at two scenarios. So on the right-hand side, a scenario where we seek to preserve environmental flows, and on the right-hand side, a scenario where instead we leave irrigation to be unbounded. We see the response on the energy implications, and basically you can see this interesting dimension that in an environmental flow scenario, actually the demand decreases because there is a decrease in the number of locations where it's possible to sustainably pump water. And you can see that better in this graph, which gives you an idea of the share of sites where it's found to be more economically feasible to pump from the underground, from the surface, or where we find that it's not possible for environmental reasons of preservation or for economic reasons as well. It's too expensive, not profitable. Okay, I'll jump to the conclusions. So we have a preliminary piece of research, but we find that there is substantial potential in terms of techno-economic potential of solar irrigation in the region, and potentially large development impacts. Some regions are hotspots of potential more than others. Nigeria and West Africa look very promising, for instance, and potential implications for food securities. We need to do further analysis to have sensitivity of these results to different assumptions and parameters and scenarios, but I think these results can be interesting from a policymaking point of view because they can inform policymakers in the support of policies to push for these technologies, to prioritize where to focus the investment, and ultimately to seek to close some of the development gaps. Thank you.
Do we have any questions?
Yeah, that was right. That's a great study. I'm just thinking about sites in West Africa that I've visited, and also areas where pumping is much more widespread, and some of the challenges that can arise once you start doing that. And maybe I missed it. Do you have anything about the falling groundwater level if there's excessive pumping? And two other things. One is the capacity to repair the pumps and get access to the parts, and where they're distant from a surface water site, just the cost of transporting the water.
Thank you. Just a clarification on the first question. You meant the geological problems if you overexploit the aquifer in terms. Okay, no, we don't consider that. We're simply getting data from the current survey of the underground aquifers geology, and we have a scenario where we say we respect the environmental flows, and one where we don't, but there is not explicit modeling on that dimension, actually, no. And on the other 2 points, so on the maintenance, let's say, of the pumps, currently what we do is simply assuming a share of the cost as operation and maintenance costs from a technical point of view, but being really aware that often an issue is that these systems, once installed, are broken, and then they remain broken because of lack of access to repairing capacity, markets. This is a techno-economic assessment. Of course, there is all the governance dimensions, which are additional, let's say. So yes. And the last point was on the where surface water is unavailable. So maybe actually it's I also have a question for the audience if you have an advice, because currently the strategy we follow is to consider both surface pumping, surface water pumping, and groundwater pumping, and then to prioritize, given certain physical limits of depth and distance, the option, the source, which implies the least energy consumption, so the most conservative one from an energy consumption point of view. So we have a cap, like water cannot be, in our model, be pumped, for instance, beneath 75 meters down and 5 kilometers up, which is already a lot. Yeah, this is like a physical boundary, let's say.
I was going to say I have no answer, but then I thought I do. The small reservoirs project from the challenge program on water and food had a study focused on West Africa where you put in some basically some catchments, micro catchments, and then there were some pumping from the seepage, the groundwater seepage in that vicinity.
Thank you. Any other questions?
Thank you. Yeah, I have one question on the market dynamics. You mentioned like sensitivities on price and on costs. So if this kind of irrigation would scale massively through West Africa, that would also have implications on supply and demand. Is that the kind of dynamic that you're looking at, or is it like a flat price type piece?
It's a great point. Actually, we are thinking about it. So currently in this, let's say, preliminary implementation that you saw, we just assumed constant demand, and the over excess of supply that we simulate in response to growing yields is not affecting the price currently. So there is no like equilibrium, new equilibrium of the market. But what we're trying to do is to either use some elasticities to simulate the response of the price to a growing supply, or also some people suggested that we might do some little CG modeling exercise to evaluate the market equilibrium. So this is forthcoming, not presented here, but very important, I believe. Yes, thank you.
Hi, Giacomo. Really nice presentation. It sort of got me thinking, because I'm originally from South Africa, and I think of obviously these water management issues, so not just on cost and where it's economically feasible, but also more social aspects or political or other barriers and opportunities that could arise with where this could be very feasible. So I'm thinking about places where water management is very poorly done, that maybe there would be even more feasibility in those regions. To what extent have you actually thought about this, and would you want to consider sort of adding a social aspect to it as well?
Thank you. Yes, that's tough actually, because in our modeling exercise, we are treating smallholder farmers as somehow autonomous actors, let's say, that autonomously decide to implement this type of technology, perhaps in a dynamic where the one pump can be shared among farmers, so this is possible. But we don't have like a central government or a central authority which is locally optimizing the situation. Like here, every location, every settlement is optimizing for itself somehow. So the dynamic is not a planning adaptation, but it's autonomous adaptation in this study. So it's, yeah, by design it's a bit different, but aware of also the fact that governments usually want to have a say, of course, in the management of water resources. So yes, you are right.
Yeah, it's actually a bit follow-up question from Nico. Like, I can imagine this is maybe a useful study for water management for government. And do you have maybe any chance to show them or advise it, or do you think about future opportunities to maybe give a content of it, or like I can imagine it will be useful, and maybe you can have more information or about policy, how are they going to make, and then maybe you can make tailored scenarios for different regions. Is this maybe a direction you thought about? Yeah.
Oh, thank you. You gave me a great opportunity to make a bit of marketing for our project, which is LIPRI project, which is this initiative I was talking at the beginning. And basically it's a European Commission funded project co-sponsored with the African Union. And the idea is to first provide these outputs somehow to the benefit of stakeholders, of policymakers. So we will have plenty of project workshops with stakeholders to disseminate these results, but also this is like a concept that we did for, as you saw, for all the sub-Saharan African region. But in our project specifically, then we are focusing on case studies, country studies. So we're working in Zambia and in Rwanda currently to do in-depth country analysis, where we tailor even more realistically the assumptions. So yeah, this is happening.
Maybe one just small suggestion. So I don't know if you're familiar with the Sustainable Trade Initiative based in the Netherlands. They do a lot of work on farmer business cases all over the world, basically, and they have these kind of connections. And I can imagine like a linkage there between the two is something they could be interested in, because they have like they look at farmer business cases on a farm-by-farm basis, have a huge database on how the farmer business case works and can develop under different kinds of under different kinds of measures, like irrigation, but they don't have a model like this. So that could be a potential, I think, something they may be interested in, and they have connections to all kinds of different stakeholders.
Thank you. Last one thing quickly, just we know that what is really important is the business models in the end to finance these things, because farmers tend to lack upfront capital, so you need business models. So yeah.
Great, thanks. Sorry, we have to move on. So now we have the final presentation from Hui Yang, who will be presenting the critical role of socio-demographic factors in determining the future health burden from ambient particulate matter. Is Hui Yang here? No? Okay. Then, I guess we have, yes, we have more time to discuss. Do you have any other follow-up questions for any of the presentations?
Thank you. Thank you. Yeah, thanks everyone for really interesting presentations. My question would go to you, actually. I hadn't thought of it before, but I was wondering, you had said that investments in renewable energy hadn't had a great impact on, and I'm not very familiar with what the energy system looks like in terms of the actors. So who are these investments going to? Is this independent, kind of new, small-scale renewables producers, or is this investments going to larger energy companies that are already also using fossil fuels? So I was just wondering a bit about the dynamics there.
This brings back memories from the workshop, I have to say, because we had some partners who work in these big companies, and then we also had small scales. But the problem is the way we formulated it. It's not clear, per definition of the variable where it would go. So, but what we agreed on in how we interpret it in the Malaysian context, it's most likely going to the bigger companies right now. And but even if part of it goes to the small one, it's just not enough to give this a push, because even if you have these smaller scale places, but the problem is that you have this rigid system by the state that only allows a certain extent. So for example, there are like limitations how much solar power can actually be fed into the grid by the rooftop. So they're like, right now they have a quota and that's reached, so you cannot actually use the energy that you put on your rooftop. So of course there's any investment that you could do will not go to these ones where you would think there's a bigger effect of terms of the energy transition, but will go to like palm oil industries and stuff that are considered sustainable in Malaysia. So there's and that are big companies usually, and then they have like this predefined kind of pattern where the energy would go. I think that's the main problem right now, that they really have these somewhat arbitrary rules how much you can feed into the grid by small scale producers.
Any other questions, comments?
I have a question for Qing Xuan. So you mentioned you worked on the residential sector as well. I'm wondering, could you expand that a little bit? Now we have more time.
We can also bring the slides up if you want.
Yeah, no, it's fine. I can. Yeah. So for the residential, we identify different energy surveys. So yeah, maybe I can actually show the slide if we do have time. Yeah. So yeah, this is actually residential, but I have to wait. Maybe. Oh. Oh, I cannot. Okay, I have to go to the end. Okay, so we do have different energy services like space heating, space cooling, appliances, water heating and cooking in our model. So by defining that, we can actually come up with different energy use or different activity level of these different energy surfaces, and also shifting mode between them. So, but unfortunately, I don't have the figure here for the result. But for the also, if I remember correctly, for non-OECD regions, there are more of course, activity increase in especially space heating and space cooling. But then in non-OECD regions, there are more energy efficiency improvement happening in 2030, and in 2050 the energy efficiency in non-OECD region kind of catch up, so they can have more emission reduction in 2050. And also by switching to less carbon intensity fuels, there's also contribution from the carbon intensity sector. So yeah, so mainly the reduction trends are from efficiency and the carbon intensity improvement. Yeah, in the residential part. So but then yeah, because this for this research or this paper, we mainly focus on the three sectors of power industry and passenger transport, actually. So yeah, the residential part is actually in next report we will publish by PPL. But yeah, it's thank you for your question. So I can elaborate more. And for passenger transport, I also have different modes. So like bus, train, car, and airplane, and the car has some more impact on emission reduction. So yeah, please, if you have more questions, you can ask me. Yeah, thanks.
There seems to be more questions.
Hi, Lara Velda from Climate Analytics. I have one question for Giacomo. So I saw that in your presentation you mentioned that for the PV generation potential you're using solar GIS, which I guess is you have to pay for the subscription, right? Or is it? Because I just wondering, because there are several like open source and open data tools available for like doing these assessments and like quite detail, with, you know, like investigating what land use you want to use, which PV panels and so on. I was just wondering why you specifically chose solar GIS for it.
I think that only for Africa, because they had a partnership with the World Bank, they can give you openly, freely, a few of their variables, not all of them, but one of them is the PV output, which is like kilowatt hour per kilowatt peak in each month. So yeah, you have Africa for free, but if you want other regions, you have to pay. Yeah. In fact, to be honest, I mean, given there are a lot of dimensions involved, the PV sizing is quite simplistic in our approach. It's not really engineering with all the little details. It's quite schematic, yeah.
I have a question for all the presenters. So at the one purpose of this whole conference is to learn what to do next with the climate scenario efforts. It's a bit of an unfair question, but you don't have to answer it now, because it kind of depends on you knowing something about the narratives and the models. But the question is, what should they be doing differently as a result of what you observe? For example, if you look at the assumptions in the IAMs about behavioral responses or the practices that they put in place, do they cover your case? And with the narratives, do they capture meaningful dynamics and responses? And I won't tell you where I sit in that ecosystem. You cannot hurt my feelings. It's impossible.
So who wants to respond?
Just to your question, because I like the question a lot. But I guess, I mean, in the theme of Global South, right? Not just what models can do, but how Global South can be more or better represented, right? So maybe just to add that to the question, and then maybe.
I accept.
Yeah. Anyone want to give it a first go?
Yeah, maybe I can start. Yeah, so by doing this analysis of our model, I think I actually thought about that. Like, we're modeling it, and then our model includes 27 regions. So also some important region from Global South, of course. But it is just the model detail represent these regions. So I think from the result, I kind of see there are different patterns. So I can imagine it catch some of the features from different regions, but it can always be improved. So I agree. Like I think in the image model of at least the model I work with, I feel we can definitely increase the resolution of some Global South regions. Yeah, that's I totally agree with you.
I guess I have an easy spot here because we modeled the qualitative stuff, and I think that's largely missing. So I think the combination should be for sure one of our goals, especially because really we have done the study in four countries from the Global South, and all of them we see different patterns, but we always talk about the Global South in general. If we are generous, we say East and West Africa, but I mean that is still a broad kind of summary. So, and they have all different institutional dynamics. And I mean, like Malaysia, when we had this like investment thing popping up, everyone, even Malaysians were surprised because you don't usually think about it in this kind of abstract thing. So I think the institutional dynamic of this is super important to quantify. And then I have a bit of because I'm a behavioral economist as well, so I think the behavior needs to be a lot better represented.
Yeah, no, I can maybe add that I'm not an integrated assessment modeler, but from my little knowledge of IEMs, often you see that these global models upon which the global policy on climate is developed, around which the scenarios are made, etc., are really poorly representing the global south in terms of data, diversity, and so the conclusions they might draw for global south might be also misleading because they treat like often, Africa as a region, and you know what it means. So I think, yeah, it might be also leading to some inequality in terms of the quality with which you model a region, and therefore the type of insights you get about the region, because just you model it poorly while maybe you do a very fancy modeling for the US or Europe. So yeah.
Any questions or comments?
Maybe I would just like to add on. So I think like listening to these different conversations, like basically an actor perspective, understanding the business case of an African farmer, understanding the political landscape, understanding the political system, the situation around it, the different futures different countries or regions can have. So that's what I really liked about Esther's approach. It's like a different kind of energy system in different places depending on what is possible, but also the culture. Like, is it more centralized or is it less centralized? And also the kind of implied bottom-up dynamics within it. So what happens at the moment? Solar irrigation skills in sub-Saharan Africa. If there's a tipping point in that system, that has huge implications. So those kind of dynamics are not represented very well in IAMs. And partially also, I think that those kind of transformation type dynamics are also considered very hard, even though sometimes change can go very quickly. So those type of suggestions I think I would have.
I would like to make a suggestion, since we have a few minutes left and we have the poster session afterwards. I would like to ask if our two poster presenters are here, Adam Suski and Dorothea Fleck. And if you want to make maybe a brief statement about what you will be showing us afterwards, so we know where to find you.
I don't know where to find me. I'm curious myself. I will present our study on the carbon border adjustment mechanism, which is currently on the table for the European Union, and the effects, especially our focus is on the distributional effects on the so-called global south, or the rest of the world, let's say like that. And exactly this impact. And also maybe the impact of transfers, because there are two proposals. I'm not sure if you're familiar with the European Union legislative process. So the European Commission makes a proposal, and then the European Parliament can make comments to it, and the European Parliament Environmental Commission added a paragraph adding questioning for transfer payments of CBAM revenue to going to low-income countries, and actually that makes a large impact. So happy to show you the results later in the poster.
Great, thank you. We're looking forward to it. Adam Suski is not here. Okay, we will wait then until the poster session. Are there any, I think we have a few more minutes, maybe any final comments, questions? Okay. Well, there were already a lot of questions and a lot of discussion, which was very interesting. I would like to thank, of course, all the presenters, but also all of you for making very thought-provoking questions, and we can continue the discussion afterwards as well. Thank you.